Right, so welcome back students. After your tricks in inorganic chemistry, now I thought I'll start with your S block chapter. So I'll be doing the complete revision of S block, then we'll start solving different types of questions which are very useful for your NEET exam. Done. So whenever you're supposed to study for S block, let us see what are the important points you need to remember. First of all, when I speak about S block, the elements which belong to S block are lithium, sodium, potassium, rubidium, cesium and francium, isn't it? Yes, so these are the elements. So what should you remember in this chapter? Let's see. First of all, when I have to go into the properties of S block elements, first important concept of this one is diagonal relationship. So you need to know the concept of this diagonal relationship of S block elements, diagonal relationship. So basically, when I have to speak about diagonal relationship, the first important thing, let us write. Now what are going to show diagonal relationship? In group 1, this is group 2, this is group 13 and group 14. This is how is the diagonal relationship shown. Element of group 1, group 2, group 13 and group 14. Done. And the period would be period 2 this way and period 3. Right, so this is the thing. Now in group 1, lithium element, right? In group 2, beryllium and magnesium element. In group 13, boron and aluminium element. Group 14 is a silicon. Now lithium is going to show a diagonal relationship with magnesium and its properties. Beryllium is going to show diagonal relationship with aluminium and its properties. Boron is going to show the diagonal relationship with silicon in its properties. Now why is it showing? Basically, we're going to speak about diagonal relationship based on two important concepts. What are they? Let's see. The first concept which you need to remember for diagonal relationship is, I'm going to speak in terms of electropositivity, that is ability to donate electrons, electropositivity, and I'm going to speak in terms of the next concept, that is polarizing power. These two are the concepts which I'll be speaking in terms of. Polarizing power, right? Fine. So when I have to speak about electropositivity, done, right? So when I go from left to right in a period, what will happen? Or when I have to speak in terms of group also. So let us see.
The biggest online platform, learning platform in India. Let's crack it. I'm Vani Potepalli, the verified educator for grade 12 students, CBSE, ICSE as well as state board students are with me.
Unacademy introduces Ask a Doubt feature, a personal tutor. Students, this is going to help you in completing your assignments, homeworks, and it will also be helping you in doing your self-study. Timings would be, it's going to start off from 6 a.m. till 11 p.m. for the whole day.
Here is a procedure, students. Step 1, go to your Google Play Store. There, download the Unacademy Learning app. Then, as soon as you open, you get started, give your mail address or the mobile number, whichever is possible. Next step, once you enter there, your Unacademy mail ID, enter, go to continue. Select your residence, where you're staying, which state. You get an OTP to your mobile. After that, search for the goal, grade 11 or grade 12. Select your language of preference. Then you would get an option, yes, welcome bonus of almost 200 credits earned. That's a additive to your account. Then you can directly go, you have the scrolling as you see, there's an Ask a Doubt feature over there. Simple as that. Enter the code, right? There's an invite code asked. Then you can click it. Yes, you're ready to get your doubts solved. What should you do, students? Wherever you have doubt, first important thing, take a picture or choose it from the gallery. Then comes your step 2, cropping the picture. Then comes your step 3, either uploading or submitting your question. Step 4, as you know, once you send students, how many of our unlimited doubts are there? Whether it is in maths, physics, chemistry or biology, select the subject which you want your doubt to be cleared. Then you can just type, right, I have a doubt. Can I get the solution? It's already there, uploaded, you sent it, you have sent it, cropped it. So automatically you get your doubts cleared from your educators. Right, students, instantly, n number of doubts, both in English and Hindi. Easy? Yes, students, follow the steps. All are available.
Yes. So there's a wonderful opportunity for you all students. You're going to ask just 10 doubts. Just ask 10 doubts and you'll be getting 15-day free subscription offer. So this 15-day free subscription offer is going to be valid till 10th March. Remember students, ask a doubt, that to 10 doubts and get a free subscription for 15 days. Utilize this opportunity. We are waiting for you students. Yes. I am there with grade 12 students where I'll be solving previous year's questions. This batch is going to continue for 2 months. All the core subjects, that is chemistry, physics, biology and mathematics are going on students. I'll be taking the sessions on Monday and Wednesday between 6:30 p.m. to 7:30 p.m. Please join me. These are the Unacademy subscription features where we have daily practice sessions, weekly mock tests, live quizzes, daily MCQs and subjective test series where a 360-degree support system would be there. So please join us students using my referral code VANILIFE. These are the Unacademy subscription pricing both for plus and iconic features. Just check here students, you have an opportunity for joining us in 1 month, 3 months, 6 months, 12 months, 15 months and 18 months. Yes, it's up to you. Please check the prices and join me. Use my referral code VANILIFE. Now, in the month of March, you'll be getting 5% discount students. So, utilize that and join me for the live classes every day. Download the Unacademy app from Google Play Store. Remember to use my referral code VANILIFE. Getting free sessions for both grade 12 students, basically in the month of March. I have scheduled so many sessions students, let us see those. This session starts on 1st March and it's going to continue almost for the whole month students. Here I have mentioned the topic, I have mentioned the date, I have mentioned the timings also. Important thing, all are free classes, please join me. Every topic whichever I deal are the most important concepts for your board examination. Let's crack board 2021. Join me students, please note all are free special classes. I'll be conducting live quizzes on different chapters of organic chemistry, which will be giving a complete summary of the chapter. Join me students for free special classes, which are there available in the Unacademy app. So as I have mentioned, this journey is going to continue till 27th March. Meet me for the special classes every day at 6 p.m. to 7 p.m. And for the YouTube sessions every day between 8 p.m. to 9 p.m. join me. The link for Ask a Doubt feature is given in the description. Please go through the link for both grade 11 and 12 students. Join me students, ask a doubt, that is 10 doubts and get free 15-day subscription on the Plus platform. Thank you so much.
So here, if I have to speak in terms of a period, right? So in a period, when I have to speak, that is from left to right. What will happen? What are the concepts which you should remember? In left to right, charge increases. Right, ionic size decreases when I go from left to right because it keeps adding to the same shell. Ionic size decreases, correct? Now when I have to speak in terms of a group, right, so what is happening? Ionic size, okay, group is from top to bottom, T to B. So what actually is this here? Ionic size increases. When ionic size increases, what is the next thing you should remember? You should remember ionic charge also increases. When these properties almost, you know, they're like the polarizing properties are almost similar. So with this concept, with this concept, how am I writing? Right, so in a period, if I have to write electropositivity, let us write that point and see. So in a period, when I have to speak diagonal relationship, you need to remember this. So electropositivity in a period, what will happen? It will decrease. Hence the diagonal relationship also, they're linked. Correct, ability to donate electrons. So this is happening, fine. When I have to speak in terms of a group, right, electropositivity increases. I already gave the reason why, isn't it? Right. So when I speak in terms of polarizing power, right, so this is in terms of electropositivity. Now if I have to speak in terms of polarizing power, so polarizing power, remember this concept. So in polarizing power, what actually is this? Polarizing power, I'm writing in terms of PP. It is directly related to ionic charge. This is the first concept which you should remember, and it is inversely related to ionic radii. Remember this concept and square of it. right? Fine. So when I have to speak about this polarizing power in a period, what is happening from left to right? As I said, it's the same thing. Charge increases, ionic charge decreases. That means when I have to speak in a period, charge, I said charge increases, isn't it? When charge increases, okay, let us write that. I said charge increases. When charge increases, it is directly related to polarizing power. So polarizing power also increases. Done. So in a group, what did I say? I said ionic size increases, ionic charge increases. So what will happen to the polarizing power? It always remains constant, because both are increasing the same rate. It always remains constant. So this was the first concept which you should remember when you're learning S block element. Remember this, right? So next important concept which you should remember is anomalous behavior of elements. So anomalous behavior of elements, of which one are you studying? You're going to study anomalous behavior of the first element of the groups. Now, the first element of the groups are going to show anomalous behavior. Yes. So this anomalous behavior is shown by which group? The first element of group 1, the first element of group 2, first element of 13, first element of 14th group, 15th group, 16th group and 17th group. All the first elements are going to show anomalous behavior. So why do they show anomalous behavior? The first concept is smaller size. This is the first concept which you should remember, smaller size. Next would be, when the size is smaller, it's very difficult for me to remove electrons. So what will happen? Ionization enthalpy would be very high. Correct. When the ionization enthalpy is very high, that means indirectly if I say smaller size, what is the next concept which I have to relate? Higher electronegativity. This is very important, right? And next important concept, absence of d orbitals or vacant d orbitals. This also counts. Because of these properties, the elements show anomalous behavior. Yes. So this is the concept which you should remember. Now these concepts, let us see the important properties of alkali metals which you should remember during the exams, because alkali metals and S block includes alkali metals and alkaline earth metals, isn't it? Right. So let us see what is the important thing which you should remember. Now let us start. First important thing, when I have to speak about alkali metals, right, group, right, in this alkali metals, what are the important physical properties? Right. When I have to speak, let us speak about different things. Let us make a column like this and remember all at a stretch. What will happen, right, in a group, right? All these are groups. So the first property is atomic and ionic radii. Remember this. So when I have to speak about atomic and ionic radii in alkali metals, the first group, that is lithium, sodium, potassium, rubidium, cesium and francium in a group, isn't it? So this is all group, right? Group 1. When I have to speak about this, atomic radii increases. Why does it increase? What is the reason? Because in a group from top to bottom, new shells are added. Right, this is okay, this is done. When I have to speak about ionization enthalpy, right, again in a group, as the size increases, so I said as atomic radii increases, right? So when atomic radii increases, what will happen? Okay, let us say this, ionization enthalpy decreases. Why does it decrease? Because as size increases, the magnitude of screening effect also increases, isn't it? Magnitude of screening effect also increases, right? So the size increases, number of shells increases. The number of shells increases, easy for me to remove the electron, right? That's why it is ionization enthalpy decreases. Now when I have to speak about electropositivity, that is ability to drain electrons, that means metallic character. So now what will happen when I say electropositivity or metallic character? That metallic character means the ability to donate electrons, isn't it? When it's donating electrons, what will happen to donate metallic property? Metallic property, it increases. Why does it increase? What is the reason? Low IP, ionization potential. I can apply less energy, right? When the energy, when the IP is very less, what will happen to the electrons? Greater tendency to release electrons. This is right. That is why when I have to say lithium, sodium, potassium, rubidium, cesium, francium. Okay, francium is radioactive, cesium. Among them, cesium is most EP. is most electropositive. It can donate electrons more when we compare to others. Right, now this is over. Let us see the next property. The next property which you should remember is hydration enthalpy. I already told in my video, that is hydration enthalpy, the trick in that video. What did I say? Hydration enthalpy or ionic size is inversely related to hydration enthalpy. This is the concept, right? So based on this, what is the order first? Ionic size is inversely related. So lithium plus is great, hydration enthalpy is small, because the size is larger, hydration enthalpy will be lesser. Other way around, if the size is smaller, hydration enthalpy will be more. So size is smaller, hydration enthalpy will be more for this. Lithium, sodium, potassium, rubidium and cesium. This is the order which you should remember. Right. Next, when I have to speak about the next property very quickly, oxidation state. Right, we very well know they show +1 oxidation state. They can lose only 1 electron. Why is this? That means it shows M+1 plus ions, this type. Why is it showing? Because ionization enthalpy is low. I can easily remove electrons from the outermost shell. Hence it's easily so. So first ionization enthalpy, first IE is low. With less energy I can remove. But when it comes to second IE, remember, second ionization enthalpy, when I have to speak, is very high. Very high. Why? Because it's very difficult to remove the leftover electron, because it's almost close to the inert gas configuration, means that particular thing. Let me take an example. Lithium, sodium. Let me take sodium. Suppose it is atomic number 11. 1s2, 2s2, 2p6, 3s2, okay, 10 and 1, 3s1. Now if I have to take out, when I take out 1 electron, this becomes Na+. Now if I try to remove 1 more electron, this is inert gas configuration, isn't it? Yes. That's why it's very difficult to form M+2 ion. That's why you don't find Na+2, isn't it? So second ionization enthalpy is very high. Hence formation of M+2 is difficult. It will not form M+2. Right? Remember this concept. Now, next important thing. After oxidation state, let us see metallic character. Next concept. So in the next concept, when I have to speak about metallic character, that is same like electropositivity. Now all alkali metals are the typical metals, isn't it? The typical metals. What is the reason for this? Why are they donating electrons? Alright, why are they lustrous in nature? Because of low ionization enthalpy. When ionization enthalpy is low, I can easily remove electrons from that. Right. So next important thing, like if I have to speak about the color property of that, or the flame test property of that. Or if I have to speak of the color property, yes, they are all, alkali metals are all colored. Why are they colored? Because, okay, let us see the color. Lithium, if I have to speak, it is caramine red. Okay. Then when I have to speak about sodium, it is golden yellow in color. When I have to speak about potassium, it is pale violet in color. When I have to speak about rubidium, it is reddish violet in color. When I have to speak about cesium, it is sky blue in color. Why are these important? Yes, why are they showing so many colors? Because the electrons, they jump from lower level to the higher level. Once they go from lower level to the higher level, when this electron jumps from lower to the higher level, yes, and after some time, what will happen? They jump back to their ground state. When they jump back to the ground state, they absorb light from the particular frequency and they start emitting, isn't it? So this is what is the reason for them to show the color property. So many colors in their properties, right? So next important property, photoelectric effect is next important concept which you should remember. Photoelectric effect. So you all know what is photoelectric effect, isn't it? The ejection of electrons when a light is incident on a particular metal. Right, so they exhibit, right? So they exhibit photoelectric effect, they exhibit photoelectric effect. So except lithium, okay, except lithium. Why is that reason? Lithium does not show photoelectric effect due to higher ionization energy, due to high, because I need a lot of energy. Size is very small. When the size is very small, it's very difficult to remove or eject that electron when the light is incident. Yes, so now the energy of the photon of the incident ray is sufficient to eject. For others, what will happen? Sodium, potassium, rubidium, cesium, right? The size is bigger, and I can easily, with ionization enthalpy is very high, so you can easily, when I eject or when I supply certain amount of incident light on the surface of the metals, they can easily eject electron from the surface. Hence remaining all except lithium. So this is the important thing which you should remember. Remaining all except lithium will show photoelectric effect. Okay, remaining will show photoelectric effect. Photoelectric effect, remember that, except lithium because of higher ionization enthalpy. Right, when I have to speak about density of these particular elements, so density, if I have to speak, yes, so densities of alkali metals are less basically, they're very less. What is the reason? When I have to speak in a group, correct, so density in a group increases. Why? Density is equal to mass by volume. Fine. So what is happening down the group? Atomic size is increasing. When the atomic size is increasing, what will happen to the atomic mass? Atomic mass also increases. When atomic mass increases means density also increases. Simple as that. Right. When I have to speak in terms of melting point and boiling point, so simple as that. Remember, melting point, when I have to speak, for the alkali metals, they have low melting point. Why is the melting point very low? Let us see. Because when I go from top to bottom, what will happen to the size? The larger atomic size, isn't it? Larger atomic size. Next, now when the size is larger, what will happen to the strength of metallic bond? Strength of metallic bond, right, decreases. Correct. When the strength of metallic bond decreases, what will happen? It causes the melting point decreases, isn't it? When the metallic bond is weak, it can easily melt that. That is why your alkali metals are called soft metals, isn't it? That is the main reason. So alkali metals are called soft metals. Why are they called? Just now I said the size is larger, metallic bond or the strength of metallic bond is lesser. When the strength of the metallic bond is lesser, that means I can easily break the bond, I can easily melt the bond, hence they are soft metals. Yes, right. So why are they soft metals? This is one of the important reasons, due to weak metallic bond. Okay, remember this concept. Yes, so with this I have completed the physical properties of your this one. Let me come back and do the chemical properties of alkali metals. Right, after the physical properties, general physical properties, let's come back to the general chemical properties. After that, I'll gradually go into the elements. So general chemical properties, when I have to speak about alkali metals, all I've combined together here. Let's see this. In alkali metals, when I have to speak about the group 1, that is lithium, sodium, potassium, rubidium and cesium, let me take the alkali metals as M. Okay, this M stands for the metal. Right, when I have to speak about the combination of the reaction with hydrogen, so metal combines with hydrogen, forming metal hydride. Remember this. When you heat this, now hydrogen is 2, so 2 here. So metal is 2, 2 is here. So here M plus and H minus. This is the formation, right? So lithium plus hydrogen gives lithium hydride. Remember this. Now the same thing, suppose if this metal hydride, if it further combines with water, then what is it going to form? It forms MOH plus hydrogen gas. This breaks up as H and OH, isn't it? MOH and hydrogen gas. That is what is the combination, right? Now the same metal, alkali metal, suppose if it combines with oxygen, it forms an oxide of type M2O. That means lithium plus oxygen gives Li2O. Correct? So balance this. So 2, metal is 4 now, 4 and oxygen is 2. Right. Suppose this particular metal oxide, if it combines with water, okay, what does it form? It forms MOH plus your lot of amount of heat is released, right? So here metal is 2, so 2 in this way, right? So just simple. This is MHOH, isn't it? So MOH and the amount of heat. Right. So next, suppose if the same metal, if I have to speak, if it is combining with halogen X2, it can be fluorine, chlorine, bromine, iodine. It's going to form salt, GMX, right? So this one X is 2, so this is 2. Done. Let's see one more. Suppose if this metal is combining, your metal is combining with ammonia, metal plus hydrogen. It's going to form a salt or complex of type metal, NH3, taken X, right? This becomes M plus and electron. I'll show you when I take an example. Just of now, remember this is going to form a complex like this. Done. Suppose if the same metal is combining with sulfur this way, it's going to form a sulfide of type this sodium, lithium sodium, isn't it? Sodium plus sulfur gives sodium sulfide, Na2S. right? This is the combination. Now let's see one more property. So these are the general things you should remember. This is where you should remember, correct? This is where you have to remember. Everywhere this is important, this is important. Okay, this is the formation, this is the formation, this is the formation, this is the formation. Here this one, you need to remember this for applying it. Now next important property of chemical property of alkali metals is, suppose if I take this metal, alkali metal, oxidizing property. What means? Loss of electrons, M++ electrons. Now this metal isn't solid. Now when the solid gets converted to metal, gas, conversion of solid directly to gas is what? It is sublimation, right? Now this sublimation is denoted by delta H sublimation. Fine. Now the same gaseous state, suppose if this gaseous ion is going to lose one electron in this way, so this becomes M+. So this is gaseous now. So what will happen? This is called ionization enthalpy. This becomes, we represent it as delta IH, that is ionization enthalpy. First ionization enthalpy. From this particular thing, if it back to this, so hydration enthalpy, this is called hydration enthalpy, correct? This is in the aqueous state. This is called hydration enthalpy. Hydration enthalpy. So this is represented by delta H hydration. This is what is important. So these are the general chemical properties of S block elements. I'll be doing further in my next class. Once we are done with the chapter, then we'll start solving different questions, different types of questions of S block. Then we'll go to P block, then D block, then F block, right? Yeah, see you back again with next video. So welcome back, students. We've already started with the inorganic series where I've explained you about, or where I've started with S block elements. I said we'll be doing S block in a nutshell. Quickly we'll finish the concepts and then start solving more number of multiple choice questions which are used for your exams. Right. So when after discussing the general properties of your alkali metals, let me come back to the important topic of lithium. Right. What is lithium? Lithium is the first element of your group 1 series. That is lithium, sodium, potassium, rubidium, cesium and francium. So why actually I already said group 1, group 2 or group 13, 14, 15, 16 and 17. The first element of all the groups are, they show anomalous properties. So let us see some important anomalies of lithium. So when I have to speak about lithium, as I said, the first important concept which you should study in terms of lithium, what is it? That is anomalous behavior of lithium compared to other alkali metals. So other alkali metals are, after lithium, sodium, potassium, rubidium, cesium, right? Why is it showing, why is it different from others? The first important concept is because of its smaller size. Right. So whenever you speak about smaller size, the concept which you should remember is, immediately you need to relate that smaller size to polarizing power. Remember that. What is that? I already said the polarizing capacity, the polarizing power is directly related to ionic charge. This is what I said, right? And it is inversely related to ionic radius. This is what I already said. Done? Second square of this. Done. So now to see if this particular thing directly related to ionic charge, and this depends again upon the atomic smaller size, isn't it? So because of this, right? Because of this concept, remember, lithium forms which type of this one charge? It only forms +1 charge, N+1. Because again when it goes to +2, the ionization enthalpy will become very high. Now tell me, after I speak about smaller size, what is the next concept? When the size is smaller, it obviously the amount of energy required to remove that electron is very high. So what will happen to the ionization enthalpy? Ionization enthalpy will be very high. Obviously it is understood, right? Compared to others. At the same time, if I have to speak about electropositive nature. So what is electropositive nature? It is the ability to donate electrons. So when I move from left to right in the periodic table, it keeps on, we already said alkali metals. Electropositivity decreases towards left to right. Electronegativity increases. Correct? Yes. Now tell me, electropositivity, if I have to speak. Electropositivity is basically ability to donate electrons. Correct? Now in case of lithium, is because the size is very small, ionization enthalpy is very high. What will happen to the electropositivity of lithium? Electropositivity, that is ability donating electrons, will be very less because the size is very small. I need to apply a lot of energy to remove the electron. So ionization enthalpy is high. Hence the electropositivity is also low. So these are the important points which makes it different from remaining elements, right? So now if I have to speak about the similarities, I already said lithium shows a diagonal relationship with magnesium, right? In what way are we saying there are certain properties which makes lithium as well as magnesium similar in nature? So let us see those. What are they? When I have to speak about the physical state of lithium and magnesium both, that means when I write both, it means I'm talking about lithium, I'm talking about magnesium also. What are they? Both are hard in nature. Okay, simple, just for your information. Next, reaction with water. We very well know lithium combines with water, magnesium also combines with water. What do they form? They're going to form oxides as well as hydroxides, both oxides and hydroxides. This is only for your general information. So oxides and hydroxides are insoluble in water. Remember that concept, right? So remember this. Why? I'll tell you why are they insoluble. So when we do questions, insoluble. But further, if I have to take this hydroxides, they further decompose. We will do that reaction also. As of now, remember this. Right. Let us see the reaction with nitrogen. So when I have to speak about nitrogen, so lithium plus nitrogen here, at the same time magnesium plus nitrogen. Simple. Now when I have to write, first let us write simple thing without LIN for this magnesium MgN. Right. So the valency of nitrogen is 3, cross it. The valency of lithium is 1, nothing to write. The valency of nitrogen is 3. The valency of magnesium is 2. Done. Now nitrogen here, it is 2, isn't it? Right. So try to write 2. Balance it. 3 2s are 6. So 6 lithiums. Now let's see nitrogen. Here nitrogen is 2. Here also nitrogen is 2. Now magnesium is 3. Let us write magnesium 3. Correct. So this is how you're going to form lithium nitride and magnesium nitride. Now, when I have to say about the formation of superoxides and peroxides, lithium as well as magnesium both will not further combine to form superoxides and peroxides. If you are given a question in the exam, so remember they will not form superoxides. They will not form superoxides or peroxides. Remember this concept, right? Yes. So now let's come back and see some more properties of lithium. So we have spoken about the hydroxides, we spoke about oxides, we spoke about superoxides, we spoke about peroxides also. Now let's come back and speak about carbonates. If the question is given, simple as that, just remember the concept, it's easy for us to apply. So when I have to speak about carbonates, lithium combines with carbon dioxide forming carbonates. So that carbonate is LiCO3. Lithium carbonate, right? Now when I have to speak about magnesium carbonate, MgCO3. So lithium carbonate, when it dissociates, correct? So how does it dissociate? Is there any mistake here? Let's see. Now lithium is +1 oxidation state, carbonate is 2. -2, isn't it? So Li2CO3 should be the +1. Magnesium is +2, carbonate is -2, so it's balanced. Now when this breaks up into lithium oxide plus carbon dioxide. Magnesium carbonate, when it dissociates into magnesium oxide plus carbon dioxide. Why did I write lithium oxygen valency is -2, lithium is +1, correct? Magnesium valency is +2, oxygen is -2, it's correct. Now when I have to speak about chlorides, right? So now chlorides, that is lithium chloride and magnesium chloride, right? So both, the important property of this is they are, they're soluble, they have covalent character in them, not the ionic character. Remember, they have covalent character and they are soluble in ethanol. So both of these have covalent character and are soluble in ethanol. Thus you'll be using it in the lab also, the solvent, right? So when I have to speak about hydrides, what does this concept of hydride mean? Basically lithium chloride and magnesium chloride, they are deliquescent in nature. What are deliquescent? When you leave the salt outside, they're going to absorb moisture, right? Why do they absorb moisture? Okay, when they absorb moisture, what happens? Lithium chloride, it's going to absorb moisture and form a hydrate. lithium.2H2O. This is water of crystallization of lithium chloride. When I have to speak about magnesium chloride, this also absorbs moisture and it forms lithium chloride as magnesium chloride 8 octahydrate. That means because of that water of crystallization, because of the absorption of water, we call them as deliquescent salts. So these are the quite common or the similarities between lithium and magnesium. Let us come back and see the anomalies of lithium compared to this and others. Right. So first I've taught you why is lithium showing anomalous property compared to other elements of alkali metals. Right. Then I taught you the similarities between lithium and magnesium, the diagonal relationship. Now I'm going to teach you how what are the properties which particularly differentiate lithium with other alkali metals. So I've picked up lithium as a heading, and this is now specifically I'll be explaining sodium, magnesium, potassium, rubidium. Right. So let us see the comparison. Now when I have to speak about lithium, the melting point and boiling point, because of the size is very small, lithium size is very small and the ionization enthalpy is very high, as I said. So melting point and boiling point are very high. Right, compared to alkali metals are a bit lower than this. Right, now next one. When I have to speak about the physical state, lithium is very hard in nature, and alkali metals you can cut with a knife, isn't it? We already studied that they are a bit soft metals. That when I have to speak about reaction with oxygen, right? So lithium reacts with oxygen to form a normal oxide like Li2O, right? So what do they form? They're going to form normal oxides of type Li2O. When it comes to other alkali metals, these alkali metals also react with oxygen, but other than the normal oxides, they're going to form peroxides and superoxides. Peroxides and superoxides. Right, now when I have to speak about nitrogen reaction, specifically the lithium reacts with nitrogen to form lithium nitride. I already showed you the reaction. Lithium combines with nitrogen to form Lin. The valency of nitrogen is 3. Lithium valency is +1. Here nitrogen is 2. Correct? So you're going to write 2. Balance it. Now lithiums have become 6. 6. Specifically nitrogen combines with this one. Lithium combines with nitrogen. These will not combine. Now when I have to speak about the carbonates, now lithium combines with carbon dioxide, or if I have to speak, lithium forms carbonate, isn't it? That is lithium carbonate, Li2CO3. Why did I write Li2CO3? Carbonate valency is 2, lithium valency is +1. Thus, when you're heating it, it further decomposes. Carbonates decompose, hydroxides decompose. Means they'll break up into 2 or more compounds. How does it break up into? Lithium carbonate breaks up into Li2O. Carbonate forms carbon dioxide. CO2 plus 1 becomes CO3. Li2 becomes Li2. But here, when I speak about the alkali metals, carbonates, they will not decompose on heating. Remember, do not decompose on heating. Right? Yes. Now when I have to speak about hydrates, I already said what a hydrate, when do the hydrates form? Because as I said, lithium chloride, magnesium chloride, all these are deliquescent. They try to absorb moisture when kept open. Right? So because of this, lithium forms a hydride combining with water called lithium chloride .2H2O. This is a hydrate form of lithium. But when I have to speak about other alkali metals, they are not deliquescent. So what is the property here? They are deliquescent in nature. They're going to absorb moisture. Here they are not deliquescent in nature. They're not deliquescent in nature. Right, after the explanation of lithium, let us see one question which is very important related to your lithium. Now what do they give us here? Lithium does not resemble with other alkali metals in the following properties. Okay, just now we have studied this resemblances of lithium with alkali metals, dissimilarities of lithium with other alkali metals also. Right, they're asking us which lithium does not resemble with other alkali metals in the following property. It does not resemble this set. Okay, dissimilarities they're asking us. Here they've given us first point, Li2CO3 decomposes into oxide with other carbonates and is soluble. We have already studied lithium carbonate decomposes into that lithium oxide and carbon dioxide. Okay, so this statement is correct. So the which does not resemble means this only decomposes, alkali metal carbonates will not decompose. So the answer also is A. Okay, right. Next one, LiCl is predominantly covalent in nature. That's perfect. It is predominantly covalent in nature. Yes, so B option also is correct. Third one, Li3N is stable enough, right? So we have already studied it when on heating it decomposes also, so combines with nitrogen forming Li3N, which is stable. That is also correct. But now here LiCl is conducting in molten state. Wrong, isn't it? We said LiCl, magnesium chloride and lithium chloride both are covalent in nature, I said. So covalent, they will not conduct, correct? Unless until it is ionic, they will not conduct. So they are both LiCl as well as molten state are in molten state, means they are conducting in molten state. That's wrong, isn't it? They are covalent in nature, so they will not conduct. So we have got three answers for this. Ma'am, what is this? We have got three answers. There are certain questions which have more than one option also right. So here in this case, A, B, C, all the three, they does not resemble with alkali metals. The fourth one, it resembles. So A, B, C is the answer. Right. Let us see one more question which is related to lithium. Here what do they give us? Identify the element X of the following. Right, let's see this. The reaction between metal X and water is quite slow. Okay, basically when I taught you in alkali metals, that is about lithium and magnesium, I said they're deliquescent as well as they form, they hydrate into a complex, that is LiCl2H2O and magnesium chloride 8H2O. This is what I told you, right? So okay, I didn't have any clue about this. Let's come back and see one more question. They said X is a reactive metal which forms three ionic oxides with composition X2O, XO2 and X2O2. Okay, they are forming oxides and peroxides, right? So we have to be very careful. What did I say? Compared to lithium and other alkali metals, they form oxides and peroxides and superoxides. I told this, isn't it? So what are the other elements of the alkali metals which form peroxides and superoxides? That is nothing but your potassium, rubidium and cesium. So the element X here is potassium, rubidium and cesium. This is the answer for this. Now suppose if I have to take this one, X is the most abundant element of group 1, I said. So among all the elements, lithium, sodium, potassium, rubidium, cesium, which is the abundant element which is present in group 1? That is nothing but sodium, isn't it? Okay, this is an answer. Now when I have to speak about the chemistry of X resembles magnesium, right? We have already studied. Lithium shows diagonal relationship with magnesium. So what will be that X here? X will be lithium. So even the first answer, the reaction of metal which will form a hydrate complex, also is lithium. So this is how you're going to differentiate and analyze the question and write the answer. Right. So one more question about your lithium chloride and basically alkali metals. Let's see this. Very interesting question. What do they give us? Among LiCl, RbCl, BeCl2 and magnesium chloride, both alkali metals and alkaline earth metals, the compounds which has greatest and least ionic character. So how do I decide this? When an ionic character question is given to you, directly your concentration should go into the concept that is Fajan's rule. Remember that. What is this Fajan's rule? What does it say? We have studied this Fajan's rule. You should remember, according to Fajan's rule, higher is the ionic size. That means the cationic size is larger. The ionic character would be more. That is what is Fajan's rule. Yes, the dragging tendency. So among this, okay, what did we say? Higher is a ionic size, means the size of the ion, cation should be larger, hence would be higher ionic character. Okay, in the reverse order, if I have to say, if the ionic size is smaller, the means indirectly they are covalent in nature, right? So the lesser side end of that. That means if the ionic size is smaller, the ionic character also will be lesser. Now what do they ask me? Which is the greatest and the least ionic character? Now I have combinations here. Now see here. Now lithium chloride is a covalent character, covalent compound, isn't it? So ruled out. This combination is ruled out. Now when I have to compare these two, and I have one more combination, RbCl and BeCl2. Here I have combination Rb and this one. Here I am ruling this out. Why? We already said they are covalent compounds, ionic as well as covalent compound also. So this composition or this combination is ruled out. So I have option between these two. Now I said, according to Fajan's rule, higher is the ionic size, higher is the ionic character. So among this, magnesium, compare beryllium and beryllium and rubidium. Which has higher ionic size? Rubidium has higher cationic size, because when I go down the group, the atomic size increases, ionic radii also increases. So when I go down, the ionic size of rubidium chloride is maximum more, isn't it? So what will happen? RbCl, larger the cationic size, higher is the ionic character. So which is the greatest? So RbCl has greatest ionic character according to Fajan's rule, right? When this is greater, again the other way around, smaller the ionic size, smaller is the ionic character. So which will have least? The combination salt, that is beryllium chloride, has least ionic character. This is how we are going to rule it out and correct the option. So the correct option is C. Right. So welcome back, students. Now after I completed the properties of lithium and its anomalous property, diagonal relationship with magnesium, now I'm coming to the topic sodium. Sodium I've already taught the preparation methods we have already studied, that is by 2 methods. Now apart from that, we are going to study the important compounds of sodium, which is prescribed for your NCERT syllabus also. What is that? Sodium is going to show us different types of the important compounds of sodium are. First is you're going to study about caustic soda, that is sodium hydroxide. You will also be studying about your washing soda, that is sodium carbonate decahydrate. Okay, that means 10 water molecules of crystallization. After that, you will be studying about baking soda, that is sodium bicarbonate. The most important concept on peroxides also you have. Yes, the most important topic you need to remember is we'll be studying with the formula, that is easy. Preparation also is easy. Physical properties, nothing much to remember. But chemical properties is where you'll be questioned. You'll be asked different chemical reasoning questions in the chemical properties. I'll be doing one after the other. Yes. So now let us start with the formula. So the first compound of sodium which we're going to study is a caustic soda or sodium hydroxide. So when I have to speak about this caustic soda or sodium hydroxide, I'm going to prepare this by a method called electrolytic method. That electrolytic method, we are going to use mercuric cell. So in the electrolysis, which electrolysis I'm performing using? I'm going to do the electrolysis process of sodium chloride, that is aqueous. So what are we going to do? I'm going to directly write the reaction now. So what happens? First you're going to take sodium chloride, you're going to dissolve it in water for the electrolysis to happen. So when this dissociates, you're going to get 3 important products. 1, 2, 3. One at the cathode and the other 2 at the anode. Remember that. First you are going to get hydrogen gas which evolves at the cathode. Remember this. After that you are going to get chlorine gas as well as your sodium hydroxide. These 2 you will be finding it deposited at the anodic compartment. Right, now let us balance. Now here hydrogen, 2 plus 2 hydrogens. Okay, let us start with chlorine. Chlorine is 2, so I'll put 2 here. Done. Now here when I have to speak about hydrogen, okay, when chlorine is 2, sodium also has become 2, so I'll put 2 here. But hydrogen is 2 plus 2, 4, so I'm going to write 2. Now it's balanced, isn't it? So this is the preparation method of your sodium hydroxide caustic soda. Done. That is by electrolysis. Now when I have to speak about the properties of sodium hydroxide, basically sodium hydroxide crystals, they're white crystals, isn't it? Right? So let me write the physical property as they are white crystalline solids. White crystalline solid. Okay, so now what is the specialty? Whenever I say crystal, we are going to speak in terms of water of crystallization, isn't it? Yes. So this sodium hydroxide crystals are deliquescent in nature. They're going to absorb moisture. So the first important second property is they are deliquescent. Now when I take the sodium hydroxide crystal, when I dissolve it in water, it immediately dissolves in water, right? So when it dissolves, after dissolving, then what we call this, then base dissolved in water is called alkali, isn't it? That alkali now is very, very corrosive in nature, right? So what should we write? Sodium hydroxide immediately dissolves in water or is soluble in water, dissolves in water. So what solution does it form? It forms an alkaline solution. That alkaline solution, when you see, they are very corrosive in nature, right? Corrosive means, you know, I think it will corrode the very, concentrated rather, right? So corrosive means eating up of, correct? Yes. Now along with that, if I have to say, sodium hydroxide caustic soda is soapy to touch, bitter to taste, right? All these are different properties. So there you can also include that, the soapy to touch, the bitter to taste, right? Still taste. Okay, simple important things. Now apart from this, now the actual concept of your sodium hydroxide starts. Let us start with the chemical properties. One question, one reasoning we have. Let us reason all those. Right, so when we come back to the chemical properties of sodium hydroxide, as I said, many reasoning questions are asked from this. Means you should know the concept of this particular reaction. Then it's easy for you to mark the multiple choice question, the correct option in the exam. Otherwise, there will be negative marking. Be very careful, right? So when I have to speak about sodium hydroxide reaction with halogen, right? Let us speak about chlorine rather, right? So very, very important thing. What should you remember? There are two conditions: cold conditions and hot conditions. Suppose if your sodium hydroxide or the caustic soda is reacting with, let me take initially the general reaction, X2, right? If it is reacting with X2 and the halogen, let it be chlorine here, this halogen is in cold condition. You're going to take the cold condition of that particular reaction. So then you're going to get three important products. What are they? The first product is 1X as NaX. The next compound is XO, and the next compound is water. Right. Now let me take this example. If X2 is chlorine, right? So sodium hydroxide, it's combining with chlorine here, and it is which condition? Cold condition, right? This is going to form a product. The first product, instead of X, you're going to write NaCl. Instead of this compound, you're going to write it as NaClO. Plus water is here. Now what is this reaction? This reaction is called the disproportionation reaction. Disproportionation. I am always this reaction. Maybe the spelling is wrong. Okay, not a problem. Check it. So this disproportionation reaction, what is that? The same atom or the same element is going to undergo oxidation and reduction. The same will undergo oxidation and the same will undergo reduction. How is this? Suppose here, what is the oxidation state of this? This is 0. Here when I have to compare, this is +1, this is -1. Here when I check both the things, I am going to get +1. Now what is happening? From 0, there is increase in oxidation number. Increase in oxidation number is nothing but oxidation. Here from 0, there is decrease in oxidation number. That is nothing but reduction process. This is reduction. Now there's such reactions where the same element undergoes oxidation as well as reduction is called disproportionation reaction. Remember this. Now condition 2, this is, let us write, this is case 1, let us take case 2. Now what am I going to do? Instead of cold conditions, I'm going to take hot conditions. Now what am I do? NaOH plus this is halogen. Now the condition is hot. Now you have to be careful. In the exam you need to observe carefully whether they've given you cold condition or hot condition. Now the product which is going to form is NaX is the same. Instead of NaXO, you're going to get here NaXO3 plus water molecule. Let me write in terms of X now. X2 is chlorine, so in substitute. This is also disproportionation, NaOH, this is Cl. Now you're going to get hot condition. Here instead of NaX, you're going to write NaCl. Instead of NaXO3, you're going to write NaClO3 plus water molecule. That's it. So this is the most important. Same product. This is different. This is same. So this is how you're going to remember. Reaction of sodium hydroxide or caustic soda with hot and cold chlorine is a type of disproportionation reaction. What is that? In which both oxidation as well as reduction occur in the same reaction. You need to be very careful when such reaction is given to you. So let us come back and do one more reaction with the reasoning question. Right, let's come back and see the next reaction. Here, what is this reaction? Here we are going to react sodium hydroxide or caustic soda with metal zinc or zinc oxide. Right. So now dioxide rather. So what should you remember? The most important concept here is we have studied in grade 10. What is this? Base plus metal gives me what? Gives me salt plus hydrogen gas. This is what you have studied. The same thing I'm applying here. So here when sodium reacts with zinc, it's going to form a salt, that is sodium zincate, Na2ZnO2. What is this? This is called a salt of this. It is called sodium zincate and hydrogen gas as usual. Simple reaction, isn't it? Right. So they may ask you the product, they'll give you the product, they'll ask you to identify. Now, when I have to come back to reaction with silicon dioxide or silica sand, here there are two conditions. Remember, the first condition is what will happen when, they may ask you directly, what will happen when your hot and concentrated sodium hydroxide or caustic soda reacts with sand? This is how they may ask you. So suppose if I take sodium hydroxide here, the condition here is concentrated and it is hot. This is the condition. Now this is reacting with silica SiO2. Now the temperature, you should remember, it's almost 900 degrees centigrade. 900 to 1000 degrees centigrade. So now what is it going to form? It's going to form sodium silicate, NaSiO2. This is called sodium silicate. Sodium silicate. Right. Now the same thing, if I take sodium hydroxide instead of concentrated, if I take dilute, now it's going to combine with SiO2 silica. Now what is the product form? The product form, or this is no reaction. There is no reaction formed in this particular thing, right? This is where you need to remember. Yes. Right, now let's come back and see one more reaction that is with aluminium oxide or alumina or aluminium hydroxide. So what is the speciality of aluminium oxide or alumina? Alumina is an amphoteric oxide. This is what you have studied. Now what is amphoteric oxide? Amphoteric oxide is something which is going to react both with an acid and a base, isn't it? Now let's see. Now we are going to take a base, isn't it? Sodium hydroxide, and you're going to combine with alumina, Al2O3, or even aluminium hydroxide. Right, and now here it's going to form a compound. Okay, amphoteric oxide, as I said, it combines with both. This, when it combines with the base, it's going to form a salt. What is that salt? The salt is NaAlOH taken 4 times. Right, fine. So this is your complex salt, which is going to combine and form this. Now aluminium is 2, so 2. Sodium is 2, so 2. This is what is the compound formed. You remember this product now. Yes. So now next important thing, what do they give us? What happens when caustic soda reacts with zinc sulfate? They may ask you in this way. So caustic soda, as we know, sodium hydroxide. Sodium hydroxide, when it combines with zinc sulfate, simple, isn't it? Sodium sulfate and zinc hydroxide. Right, till now that is more than that we need to remember. So sodium Na2SO4 plus zinc hydroxide. Zinc hydroxide, the valency of zinc is +2, so 2. Or hydroxide is -1. Right, now this zinc hydroxide, further if you treat it with sodium hydroxide, excess sodium hydroxide, if you are treating, it's going to form a salt, that is sodium zincate, again Na2ZnO2. Sodium zincate is the next important product form. So remember this. This is again one more important reaction which you need to remember. Right, now let us see the next question, next reasoning question of sodium hydroxide. If they ask you, Can tin be dissolved in caustic soda? Yes, I'll say the answer is yes. What is the type of compound or product form? The product form is called sodium stannate. A coordinate covalent complex is formed. Let's see. Suppose when I take tin, SN, I'm going to combine with sodium hydroxide. Here, what is the important thing? Here, you need to have this whole thing dissolved in water, aqueous solution of that, right? So now these two are going to combine. They're going to perform two important products. The first product is Na2, right? SN inside the bracket, OH taken 6 times. This is called sodium stannate. Sodium stannate, right? Along with this, you're also going to get the leftover hydrogen gas. Remember this. Now let's balance. Now sodium is 2, so 2. Now here hydrogens are, if I have to take 2 plus 2, 4 only. Fine. So now what happened here? OH is almost 6, isn't it? So what should I do? If I have to place this 4, okay. Now see here 4. Now let us place 4. Now 4 2s are 8, 9, 10. Correct. 4 2s are 8 and the complex, yes. 2 4 2. This should be 2 only, isn't it? Now this is right. 2 2s are 4 plus 6 10. 4 2s are 8 5 8 9 10. Right. This is the balanced reaction. That is your sodium stannate. Now second reaction. Reaction with FeCl3. In this reaction, what is this type of reaction called? This reaction is called double replacement reaction. Double replacement reaction. Simple. Nothing big in this. So sodium hydroxide, you're going to dissolve it in ferric chloride. What do you get? You're going to get NaCl and ferric hydroxide. So what is the valency of this in ferric? I said no. So it is FeOH taken thrice. Ferric. Okay. Then NaCl will be the leftover product NaCl. So 3 chlorines are making this 3. Here I'm 3 sodiums. I'm making this 3. Now hydroxyl group is 3. 3 already. Fe is 1. 1. NaCl is 3. 3. So this is the balanced equation for the reaction between ferric chloride and sodium hydroxide. Very important, sodium stannate. Please memorize it. Practice it more number of times. You will get the reaction. Right. Now let's come back and see this reaction. So in this reaction, what is the importance of this reaction? Here you need to remember what will happen when sodium hydroxide or caustic soda reacts with carbon dioxide. Here there is a difference in pH which you should remember. What is that? In this first case, the pH, if the pH is less than 8, that means it is a dilute solution. Now in this particular case, if the pH is greater than 10, what will happen? Right, there are 2 ways or 2 different products formed. You need to be careful in the given option in the question. What is this condition? When the pH is very less than 8, that means you're going to pick up a dilute solution of sodium hydroxide. Here, if the pH is greater, that means you're picking up a concentrated solution of sodium hydroxide. Let us see the products formed. First of all, this carbon dioxide, it's going to react with sodium hydroxide, I said. Right. Now what is this? This is dilute. But here, the most important thing, this is not going to directly form the product, but it's going to undergo 2 steps. In the first step, this is going to form carbonic acid, right? So this here H2CO3 carbonic acid. Now in the second step, this carbonic acid is going to combine further with your sodium hydroxide. Then it forms sodium bicarbonate, that is your baking soda, as well as water molecule. But when it comes back to your pH greater than 10, this carbon dioxide directly combines with sodium hydroxide, same thing. Now, instead of carbonic acid, here the product formed is this directly because the pH is very high and it is concentrated in nature. This sodium bicarbonate now further combines with your caustic soda, sodium hydroxide, and you're going to get a product that is Na2CO3, sodium carbonate, as well as Na2CO3 is out and water molecule. So this is where you need to be careful in defining or finding the product. Less than 8, these are the products. Greater than 10, concentrated, these are the products. Right, now let's see this reaction, that is reaction with carbon dioxide. Now what should you remember in this? So whenever a carbon dioxide is reacting with caustic soda, there are 2 important conditions which you should remember. What is that? It can be dilute sodium hydroxide reaction and concentrated sodium hydroxide reaction. So when I have to speak about dilute sodium hydroxide in the exam, if they give you a condition that if it is pH is less than 8, remember, if the pH is less than 8, that means I'm going to give you, or we are going to pick up dilute solution of sodium hydroxide. If they're giving you concentrated, that means the pH is greater than 10. Right? Fine. So remember this. Now when I take this carbon dioxide with dilute, it will not react directly. First important thing, it's going to combine with water and form carbonic acid. Now this carbonic acid is going to combine with your caustic soda and then form products. What is the product? It's going to form NaH or NaHCO3, that is sodium bicarbonate and the leftover water. NaHCO3 and water. That's the first important thing. Now when you take the P concentration of sodium hydroxide higher, that means concentrated, your carbon dioxide directly combines with the sodium hydroxide concentrated. And what is it going to form? It's going to form sodium bicarbonate, NaHCO3, NaHCO3. Now this sodium bicarbonate is going to further react with this caustic soda. Concentrated, isn't it? It's going to react further and it's going to form a product that is Na2CO3, sodium carbonate, and the leftover is water molecule. So this is where you need to remember the product. If it is lesser than that dilute solution, the product form is two-step. This is also two-step, but in the first one, sodium bicarbonate is formed in the second step. In the second case, sodium bicarbonate is formed in the first step only. Right. Now when I have to do the next reaction, what is this reaction? Reaction with carbon monoxide, simplest reaction, right? Let's see. When sodium hydroxide reacts with carbon monoxide, it's direct addition, nothing to do. HCOONA. Sodium formate is a product formed. What is this? It's going to form a product that is sodium formate, nothing else to remember. But here, this is important now. What is this? When I'm going to take caustic soda, that is sodium hydroxide with sodium sulfur dioxide, here also direct, nothing to do, addition. Here, just see here, Na2SO3. Na2SO3. Let me write that. Sodium sulfide. Now sodium is 2, so I'm going to write 2 here. Right. So along with that, water molecule also is here. Done. But now what is important? When it reacts with sulfur, this is where you need to be careful. When it reacts with sulfur, right, the colloidal sulfur, this particular reaction is called disproportionation reaction. The same thing which we did, where same sulfur is going to undergo oxidation as well as reduction in the same reaction. What is this? The first product which it forms is sodium sulfide, Na2S. The next reaction or the product which is going to form is sodium sulfite, Na2SO3 and water molecule. Now let us see. Here the sulfur oxidation state is 0. Here when I have to take Na2 is +2, so this becomes -2. Now in this case, when I calculate, this is +4. Now see, from 0 to 4, increase in oxidation state. So this is oxidation process, oxidation reaction. Here from 0 to -2, it is decrease in oxidation state. So this reaction is called reduction. Both oxidation and reduction is happening in the same reaction. So this type of reaction is called disproportionation reaction. Yes, so very important reaction. Please try to memorize it. Right. Now let's see this reaction. What does this reaction teach us? Now in this particular reaction, I already taught you reaction with sulfur and sulfur dioxide. Now very specific reaction. What is this? Now whenever sodium hydroxide, basically whenever this is quite common to all the reactions. Whenever there's some reaction between two reactants, what conditions depends on? It depends upon temperature. Correct? It depends on. It is every reaction specific with certain temperature. It is specific with certain pressure. It is also also specific with stoichiometric ratio, isn't it? We need to see that balanced reaction, stoichiometric ratio also. Right. Now there are two conditions. What are they? First important thing, if sulfur reacts with sodium hydroxide, I am speaking about balancing the sodium hydroxide. One more sulfur reacts with sodium hydroxide. I am going to take different moles of this. Right, let us see the product. Three important products are formed. First, for this, it is going to form sodium sulfate. Here, when I change the number of moles, let me balance this. When I change the number of moles, the product formed is Na2S2O3. And the leftover sodium sulfide, here also sodium sulfide, here water molecule, here also water molecule. This is quite common. What is this? Now let me balance this. When if the balancing is here, in both the cases, stoichiometric ratio is different. So here in this case, the first product formed is sodium sulfate. Now here in this case, what is the type of product formed? This is called sodium. S stands for thiosulfate. Sodium thiosulfate. So this is sodium sulfate. So remember this, sodium sulfate and sodium thiosulfate, two different products. So let us come back and balance the reaction. Right. Now I've balanced the reaction. Now this reaction, suppose further, if I'm going to treat it around 600 degrees centigrade, right? So what will happen to this sodium thiosulfate? It's going to again break up into sodium sulfate and colloidal sulfur. Right, this is how it's going to further decompose into. Right, so these are the reactions for sulfur, which depends upon temperature, it depends upon specific pressure and stoichiometric ratio. This is the concept which I picked up. If it is 8 moles, I'm going to get sodium sulfate. If it is 6 moles, I'm going to get sodium thiosulfate, which further decomposes or converts into sodium sulfite and elemental sulfur. Right, so please note the reaction. Right, now this particular reaction I've already written this. I want to explain something important in this. Now when sodium hydroxide reacts with white phosphorus, right? So we have white phosphorus, red phosphorus, black phosphorus also, isn't it? Right, when it reacts with white phosphorus with the unit P4 unit, there are two products formed, right? Now what is this here? What should you remember? Here the sodium which you're going to take is cold and concentrated solution. This is what you're going to take, sodium hydroxide. Now there are two different products formed. In the exam, you have to be very careful, right? Phosphorus is white in both the cases, right? The stoichiometry is different in both the cases. But the product formed when you're taking 8 moles of sodium hydroxide, the product formed after balancing, right? What is this form? What is the name of this? Disodium. Name this as disodium hydrogen. What is this? This is phosphate. Now, what is this compound? When you're taking 3 moles of this, the product form is called phosphine. And name this compound. The name of this compound is sodium. There is no disodium. It is only sodium. It is 2 sodiums here, so disodium. Here, this is only sodium. Hydrogen phosphite. So remember this, right? So depends upon the stoichiometry of the reaction. When it is 8 moles, you're getting disodium hydrogen phosphate. When it is only 3 moles cold condition, you're going to get sodium hydrogen phosphite. So these are the products. Please try to practice it. You will get to know the product. Right, now let's see this question. What does this question states? Write the reaction of boron family elements with sodium hydroxide. Okay, right. So boron family, what is that boron family? Boron, aluminium, gallium, indium, thallium, isn't it? Right. So they're asking us only to speak about our boron family, the first 2 elements. That means they want us to show the reaction between boron and aluminium, both. Why am I not taking the remaining elements? Because they lie very much low in the electrochemical series. They can't replace your sodium, isn't it? So I'm ruling out the remaining. So the leftover is boron and aluminium. Let us pick up. So first important thing, I'm going to take sodium hydroxide. I'm going to add boron. In the second case, we are going to take sodium hydroxide. You're going to write aluminium. As I said, remaining all, they lie in the lower in the reactivity series. The lower one can't replace the higher one, isn't it? So left out. Now what is the product form? Here in both the cases, hydrogen gas is evolved. Done. So now next important, this is going to form a salt, that is Na2BO3. This is called sodium borate. This is also going to form a salt, that is NaAlO2. This is sodium aluminate. What is this? This is called sodium borate, and this is called sodium aluminate. So remember this, aluminate. So in both the cases, hydrogen gas. Now let us come back and balance this reaction. Right, now let's see this reaction. There is a reaction with ammonium chloride and sulfuric acid. Done. So I've covered all the major reactions or major products which you should remember. Right. So what is the specialty of this? Basically, whenever a sodium hydroxide is reacting with ammonium chloride, there are two products formed. Right. So there are two ways to form the products. Just see. First case is this is going to combine with this one by double displacement reaction. This is going to form ammonium hydroxide plus ammonium chloride. This is this, right? The pungent smelling gas. Now, second important thing, this sodium hydroxide also combines with ammonium chloride and it releases or it forms pungent smelling gas, that is ammonia gas, right? Fine. So you have sediments of ammonia also released, isn't it, from the kidneys? Yes. So this particular thing, what does it form? The product first formed is ammonia. This is your smelling gas, right? Ammonia gas. Apart from this, this is also going to form just like this. Ammonia as one is over. The next O, NaCl. So I wrote this wrong. So this is NaCl, isn't it? Yes, I'm sorry. So next to salt is NaCl along with this water molecule, right? Let's see. Ammonium hydroxide, double displacement reaction, sodium chloride out. In this case, as I said, this also forms ammonia gas, the pungent smelling gas, right? And NaCl as well as water molecule. This is one type of product formed. So any option may be given in the exam. You need to put the tick in the right option. Now, when I take sulfuric acid reaction, so basically sodium hydroxide, quite common reaction, a base reacting with an acid, right? Acid plus base, what do we get? We get salt plus water, isn't it? Nothing big in this. So this is sodium sulfate plus water. Directly you write the product. But what is important here, you need to remember, when a base, like suppose here you're taking sufficient quantity of base and sufficient quantity of acid, both are combined together to form salt plus water. But now if you're giving insufficient amount of sodium hydroxide, you're not giving the required amount, insufficient amount of sodium hydroxide here, then what happens? It's not going to form a product directly like this. In the exam they may give you, if insufficient quantity of sodium hydroxide or caustic soda is given to you, predict the product formed. This is where you need to be careful. What is the product form? Now let us take sodium hydroxide. I'm going to take sulfuric acid. Right. Now here, instead of sodium sulfate, it's going to form sodium bisulfate, NaHSO3, right, along with this water. This is where you need to be careful enough. Now let's come back and study the next compound of sodium, that is sodium carbonate. What is this? We're going to study about washing soda. So the formula which we studied in grade 10, that is sodium carbonate 10H2O, that is decahydrate. This is the water of crystallization part of this. So when we say water of crystallization, we can say it is sodium carbonate is a white crystalline solid. Okay, let us write that. White crystalline solid. Okay, right. So when I have to write the compound already written, Na2CO3.10H2O. Now what is the preparation? So the preparation which we use for this manufacture of sodium carbonate, that is washing soda, is called Solvay process. So we are going to use Solvay process for this. So what is the method? I'll just give it simpler. I'll make it simpler and write it. In the Solvay process, Na plus, I'm going to write the ionic reaction. And this is going to combine with Cl minus. Along with that, ammonium plus and hydroxyl. In the step 1, what will happen? Just see, right, HCO3, Na2CO3, right? So ammonium chloride, fine. So let us combine along with that carbon dioxide also. Now see, Na is like that, Your Cl minus also is like that. H2CO3, okay, or HCO3. Let us write HCO3 minus, HCO3 minus and NH4 plus. This is like this only, right? Now, what is happening? In the second step, this Na plus is going to combine with your HCO3 minus. Let us write this as step 1. Let us write this as step 2. Okay, the Na plus, okay, this step 3, let us write this as step 3. Fine. In step 3, when sodium cation combines with bicarbonate, this is going to form sodium bicarbonate, NaHCO3. Sodium bicarbonate. That is baking soda. Now, this baking soda, further what happens when you heat baking soda, right? This decomposes, baking soda when you're heating, this decomposes into your hybrid sodium carbonate, washing soda plus carbon dioxide plus water. So this is the product to 2-suit-2. This is how you're going to prepare. Step 1, step 2, step 3 and step 4, right? Fine. So now when I have to write the physical properties of this, sodium carbonate decahydrate is a, as I said, it's a white crystalline solid and it readily is soluble. Washing soda obviously readily is soluble in water. Okay, this is also fine. But what is important to remember, as you increase the temperature, the solubility decreases. That is what is important. As temperature increases, solubility decreases. I'll tell you why this reason also. So let us come back and meet with the chemical properties. Start with the chemical properties. Again, let us see the reasoning equations. So in the washing soda, the first important thing, sodium carbonate does not directly, hence it will not react with water. So how is this reacting? It's going to washing soda, ma'am, you're saying how is it reacting? But it reacts only by a process called salt hydrolysis. Let us see that. Salt hydrolysis. Right, what is this? Now basically I'm going to take sodium carbonate, I'm going to combine with water. Right, now here what do we have? We have a combination of salt of, what is this? Carbonate has come from which acid? From weak acid. Salt of weak acid plus strong base, isn't it? Strong base. Right, so together when they combine with water. What is this? Water can be written as HOH. Now what happens? Sodium comes out as sodium hydroxide and the leftover comes out as carbonic acid, H2CO3. So NaOH is out and carbonic acid is out. Now see, sodium hydroxide is a strong base. What is this? This is weak acid, right? So overall, when I have to see the reaction, this is the product formed as sodium hydroxide. That means the pH of the solution is automatically, obviously alkaline in nature, because it is a strong base. Now when I have to calculate the pH, what is the formula for this? Half of pKw in the numerical, if they give you a numerical, plus half of pK plus half of log C. This is the formula. So the overall reaction will be alkaline in nature. Back and see the reaction of sodium carbonate with sulfur dioxide and reaction with sulfur and water. What is the specialty about this? We'll see. Now, if sodium carbonate decahydrate 10H2O, part of the crystal, if it's combining with sulfur dioxide, right? Simple. The same thing if sodium carbonate is combining with sulfur dioxide in the presence of water. Simple. Products will be different, isn't it? Right. So when this combines, you will get, that is Na2SO3 plus carbon dioxide. This is what you get. Now if you have water in this, the product formed is NaHSO3 sodium bisulfate plus carbon dioxide. This is what is important, which you should remember, right? Now when I have to come back with the reaction of sulfur with water, so sodium carbonate decahydrate, yes, it reacts. This is a part of the molecule. I'm not writing every time. When it combines with this elemental sulfur, colloidal sulfur, water also is present. This is going to combine and form a product that is a bit different, Na2S2O3. What is this? This is called sodium thiosulfate. I already wrote this product earlier, sodium thiosulfate. So please remember, I've given both the combinations so that it's easy for you to memorize in the exam. See the next reaction. So what is this reaction with calcium hydroxide? Suppose when I take Na2CO3.10H2, a part of the molecule, combining with calcium hydroxide. Don't get confused, nothing here. So this is already a part of the molecule, just simple. It's going to form calcium carbonate plus sodium hydroxide, nothing else. Simplest reaction, and you need to balance that, right? Nothing else. Suppose if you have reaction with silica, sand. When you're dissolving sodium carbonate, washing soda with silica, SiO2, it's going to form a product called sodium silicate, Na2SiO3, sodium silicate. So this is a simple thing, and the leftover, if I have Na2SiO3, so the leftover is carbon dioxide. Remember this. So these are the products. So let us name this sodium silicate. Right? Fine. Let's come back and see the last set of reactions. That is what happens when you decompose sodium washing soda. What is that? Suppose if you are trying to decompose this Na2CO3 washing soda 10H2O, when you are heating this, okay, when you are heating this, we very well know the simplest reaction. It's going to further decompose and this water of crystallization evaporates. What are you left with? You are left with Na2CO3 plus 10H2O. This is simple decomposition reaction. Now let's come back and learn the next compound of sodium, that is your baking soda. So baking soda is nothing but sodium hydrogen carbonate, isn't it? That is NaHCO3. So in baking soda, same as usual, we need to learn the preparation, physical property as well as chemical property, right? So when I have to speak about the preparation, let me make this line. I need this line, yes. So in first important thing, in preparation, the same thing which we have studied, you're going to take NaCl. Along with that, ammonia is added, water is added, carbon dioxide also is added. Now, this forms NaHCO3, sodium bicarbonate. Right, this is the product formed. Right, now along with this, now sodium bicarbonate, there's one more method also to prepare a sodium bicarbonate baking soda. What is that? Sodium carbonate combines with carbon dioxide and water. Then directly this forms NaHCO3, so baking soda. Simple as that. Now when I have to speak about the physical properties of this, right? So baking soda, as we know, it is white crystalline but less soluble in water than compared to sodium carbonate. So we will write white crystalline solid, less soluble than sodium carbonate washing soda, right? Fine. So now chemical properties. First of all, whenever I take sodium bicarbonate, simple decomposition reaction, when you heat the sodium bicarbonate, it dissociates into the reverse order. The same reaction, it happens in the reverse order, that is sodium carbonate plus carbon dioxide plus water. The same reaction, both are same, right? So now, what is the special important reaction you need to remember? Sodium bicarbonate or baking soda is a diprotic salt. First of all, before that, I'll tell you something here. So because of the release of this carbon dioxide, that is why we use baking soda in the preparation of cakes, that is pastries, isn't it? Why do we use? Because of this release of carbon dioxide, it makes that cake fluffy or soft. This is what you have studied in your grade 10. So why do we use baking soda? The main application, to make the cake fluffy. Why is it fluffy? Because from the pores of the cake or the pastry, this carbon dioxide bubbles are going to evolve out. So once the bubbles are evolved, that makes porous and makes it soft and fluffy, right? So I said sodium bicarbonate is diprotic in nature. What do I mean by this? That means this is it's going to accept as well as release protons. There are two ways. What is that? NaHCO3 breaks up. Then how does it break? And break into Na plus HCO3 minus. So this HCO3 minus, it will accept proton. Correct, right? So this becomes H2CO3. Carbonic acid further breaks up. Now it is accepting proton. Now again this is going to release proton. So because of this nature, I am telling that baking soda it accepts and as well as releases, diprotic in nature. So this is about your baking soda. Not much important. When we do your MCQs, I'll be using this data for solving your MCQs. See the chemical properties of alkaline earth metals. So when I have to speak, what did I say? I said alkaline earth metals are divalent cations. Divalent. The charge would be divalent cation M plus 2. Remember this, it's easy. Now when alkaline earth metals react with water, so what is this? It's going to be just like HOH, isn't it? Yes. So your alkaline earth metal, let me take this as M. Right, this combines with OH. So what will happen? MOH. The valency of metal is also plus 2 and this is OH minus. So this becomes MOH taken twice. Right. So the leftover hydrogen gases evolved out. Now when it comes to Cl, metal plus this chlorine, this is going to form as MCl2 because metal valency is 2 and hydrogen gas. So this metal can be all the alkaline earth metals. When it comes to sodium hydroxide and water, you have to be very careful. Only beryllium is a salt which reacts with sodium hydroxide plus water, that is Na2, beryllium, OH taken 4 times plus hydrogen gas. This is what is going to form. Only beryllium reacts with sodium hydroxide and water. Now let us come back to oxygen. The valency of the metal is plus 2, oxygen valency is minus 2. So the salt formed is MO. Now again here in hydrogen case, metal valency is plus 2, it forms MH. The valency of metal is plus 2, hydrogen is again they're going to combine together, isn't it? So it's going to form MH, that is the product formed. Right, now let's come back. After your alkali metals, let us come back and learn alkaline earth metals. So once we are done with alkaline earth metals, then we'll start solving different multiple choice questions. So under alkaline earth metals, as we know, we have beryllium, magnesium, calcium, strontium, barium and radium. So flame test colors are given, just go through it once. Right, so when I have to speak about alkaline earth metals, when I have to read the physical properties, first important thing, atomic and ionic radii. So now we very well know when I move from S block, that is alkali metal, to alkaline earth metal, that is from in a period, that is from left to right, what will happen? Always the electron adds to the same shell. So atomic radii, that is compared to alkali metal. That means when I have to go, okay, let me not write like this, compared to alkaline metal, when it goes in this way, atomic radii or ionic radii decreases. But when I go down from top to bottom, the number of shells increases. So what will happen? From top to bottom, the atomic radii or ionic radii increases because number of shells are increasing. When I have to speak in terms of electropositivity, right, means ability to donate electrons. Now tell me, when the size is smaller enough, it's very small, the electropositivity will be less than alkali metals because the size is compact in nature. So from left to right in a period, this is I'm moving from this left to right. So what will happen? The electropositivity decreases because the size is small, it can't donate electrons. But when I go from top to bottom, electropositive character, it increases, EP increases. Why? As the size increases, it is easy, number of shells increases. When the number of shells increases, ability to donate electrons increases. When ability to donate electron increases, what property changes? That is metallic character increases. So metallic character increases. Done. So ionization enthalpy, same concept. When the size is smaller enough, because I need like the electron every time it's getting added to the same shell. When it's getting added to the same shell, what will happen to the amount of energy required? The amount of energy required will be more, isn't it? Right? So when I see the ionization enthalpy, when I have to move from left to right in a period, ionization enthalpy value is more. Because why is this? Because atomic radii, let us write that since atomic radii is less. Correct. But when I have to move from top to bottom in a group, same concept, number of shells increasing, size of the atom is increasing, so I can apply less energy to take out the electron. So ionization enthalpy value down the group increases. So it decreases, I should write, very less down the group. So this is in the group, this is in the period. So let's come back and do the next physical properties of alkaline earth metals. Right. let's come back and see the next physical property is electronegativity. So when the size is smaller enough, what will happen? The ability to drag the electron pair will be more. So higher electronegativity will be higher in alkali metals, that is in a period, if I have to speak in this way, higher than alkali metals. Okay, let us write that, higher than alkali metals because the size is smaller. Done. So when I have to speak about the physical state, they're all silvery metals, right? So silvery, and next important thing, they are, you know, when I have to speak, I can cut with knife. So soft metals, they are soft. But they, when I have to speak about in comparison with alkali metals, comparison to alkali metals, they are hard metals in comparison to alkali metals. Right. So when I have to speak about melting and boiling point, now size is smaller, the nuclear force of attraction will be more, so obviously the melting and boiling points will be higher than alkali metals, right? When I have to speak about the density, what we know, density is equal to mass by volume. Yes, so directly related, as a mass increases, atomic number increases means mass increases. That means even the density is higher than alkali metals. So let us come back and see some more properties. Right, now let's come back and see the next properties, that is conductance. So conductance, they are good conductors of heat and electricity. So let us write this, good conductors of heat and electricity. Right, when I have to speak about the oxidation state, we very well know +2 oxidation state, isn't it? So all are going to form divalent ions. That means, how is this divalent? They are M+2 ions, beryllium +2, magnesium +2, calcium +2, in that way, right? So now what is the valency? When I say divalent, the valency would be +2, simple. When I have to speak about the color property, now I said divalent atom. When it is divalent, obviously they are diamagnetic in nature, isn't it? So they all form divalent, all they are diamagnetic in nature. And when they are diamagnetic in nature, automatically what will happen to the color property? They are colorless in nature. And when is this condition? When the anion present in that should be colorless. That is important. The anion is colorless, then only it will show that particular property. So with this note, physical properties are done. Now let us come back and do the chemical properties of alkaline earth metals. Right, so welcome back, students. After your inorganic reactions made easy, let us come back and start with this concept. Now I said we need to study about the chemical properties of alkali metals as well as alkaline earth metals. That is where you'll be questioned, right? After completing the chemical properties of alkali metals, I also gave you the general information about the trends of alkaline earth metals, right? Now after the trends, now let us come back to the chemical properties, very important, right? In chemical properties of alkaline earth metals, what are we going to learn? We are going to learn about hydrides, oxides, hydroxides, reaction with water, carbonates, sulfates, halides, nitrides, and complex compounds, right? Yes. So when I have to speak about hydrides, basically all the things, anywhere, any question may be asked to you. So let us see. So when I have to speak about hydrides, how is an hydride formed? So basically when I have to write the hydride form of this, yes, we very well know. Let me assume the alkaline earth metal as M. So M stands for metal. It can, let it be alkaline earth metals. It can be beryllium, magnesium, calcium, strontium, or barium, anything. Now when it combines with hydrogen, right, it's going to form a hydride. Now this is your hydride, metal hydride, right? Now, so when I have to speak about all the elements of the alkaline earth metals, suppose if I have start from first, magnesium hydride, MgH2, right? So beryllium hydride also. So let us start with beryllium hydride because that is the first element. Let me explain about this. Beryllium hydride. Basically, this formation or this particular metal plus hydrogen, this particular thing, it's possible with magnesium, it's possible with calcium, strontium and barium, right? All these will combine. But when it comes to beryllium, formation of beryllium hydride, it will not directly react. Remember that. So what does it do? First of all, it's not going to form directly with this, and it's going to combine with a reducing agent like lithium aluminium hydride. So lithium aluminium hydride is a reducing agent, correct? Now what am I going to do? I'm going to take, let me take this as beryllium chloride. So what is the role role of lithium aluminum hydride? It has to add hydrogen to beryllium, correct? So let's start. First of all, it's going to add, because I need to prepare BeH2. Normally remaining all will be prepared like this: magnesium plus hydrogen, calcium plus hydrogen, strontium plus hydrogen, barium plus hydrogen. But here in this case, lithium aluminum hydride, being a reducing agent, is going to add hydrogen, and we're going to get BeH2. Done. Yes. After that, lithium chloride. After that, aluminium chloride. So all these three are formed. So remember this is the first, this is how beryllium hydride is formed. Now when I have to take the nature of these hydrides, right, the first hydride, magnesium hydride, this is ionic in nature. No, this is covalent, right? Yes, covalent, because the bond formed is covalent. Yes. When I have to speak about after this in magnesium, then next we have calcium, strontium and barium. Calcium hydride, strontium hydride and barium hydride, right? Right. So all these are ionic in nature. But what is the speciality? Most important thing you have to remember, you may be asked, what is the nature of calcium hydride? When I have to speak about calcium hydride is also called as hydrolith. What is this? It is called hydrolith. What does hydrolith means? Hydrolith means something which can act as a reducing agent. When I call something as a reducing agent, that means what is it releasing? It is releasing hydrogen. So calcium hydride is called hydrolith as it is acting as a reducing agent. That means it is releasing hydrogen. So that's why we call it as hydrolith. Remember this equation, right? So among the options, hydrolith, it's easy, right? So apart from this, when I have to speak about, or when I have to take magnesium hydride, let us see. Suppose when I have magnesium hydride, right. So now when I have to speak about magnesium hydride, as I said, let us see. If I take this magnesium hydride, and which suppose, let us assume we are combining it with water, dissolving it in water, hydride and water. So what is going to happen? It's going to just see here, it's very easy, nothing else. First important thing, when you dissolve something in water, it will break up into ions, isn't it? So first ion which is formed is Mg+2. Apart from this water molecule can be written as HOH. So this comes out as OH minus, right? And after that, what is left out? There's one hydrogen here, there's one hydrogen here. So what am I going to write? 2 hydrogen, correct? So now let us balance. So 2 2s are 4, correct? So to balance this, I need to balance this hydrogen also, OH. Then again this also. Now count, 2 2s are 4 hydrogens here, 2 2s are 4, 5, 6. 5, 6, 2 to the 4, 5, 6. This is how it's going to balance. Now the same thing. Suppose if I am going to take calcium hydride, let me take hydrolith now. When I am going to take calcium hydride, when I am going to dissolve this in water, so what are the ions formed? It's going to break up into calcium +2 ion plus, it's going to break up into OH minus ion plus the hydrogen gas, whatever is there, is going to be released out, correct? So now to balance 2, 2 and 2. Now let us see here, water molecule, let me write this now normally. Now water molecule, 2 2s are 4 plus 2, 6. Here water molecules, 2 2s are 4 plus 2, 6. So this is how you're going to see. This is how the hydrides are going to, when you dissolve, you get the respective ions. And calcium hydride is called hydrolith, and these are the basic things. Now let's come back and learn about oxides of alkaline earth metals. Right. Let's come back and learn about the oxides of alkaline earth metals. So when I have to speak about the oxides, normally because we very well know, according to this one, the first element is beryllium, magnesium, calcium, strontium and barium, right? So when I have to speak about beryllium is kinetically inert towards oxygen. Reacting with oxygen, it is kinetically inert, right? So we need to supply certain conditions, then only it's going to react, right? So it forms, it's inert, but supplying certain appropriate conditions, it forms. Why? Because then oxide layer forms on the surface of that. That's the reason it is chemically inert, right? So now when I have to speak about the oxides of this, now it's going to form 2 types of oxides. What are they? Metal plus oxygen giving me metal oxide, okay? 2. So this is one type. So which one will form this? The metal can be here. It can be, if I have to write, it can be beryllium, magnesium, calcium, right? So when I have to speak about the second type of metal oxide, it is again metal plus oxygen giving me MO2. Here, strontium and barium. Okay, strontium and barium are going to form this type of oxides. Fine. So now what are the different types? If I have to speak about the nature of these oxides, nature, beryllium oxide, right? It is amphoteric in nature. Amphoteric means it's going to react with both acid and base. Amphoteric. Fine. Next, magnesium oxide, calcium oxide, strontium oxide, barium oxide. Both the valency +2 and -2, they get cancelled, right? So remaining all, when I have to speak, they're basic in nature. They're basic oxides. Now when I have to speak about the amphoteric nature of beryllium oxide, as I said, how is this reaction? Basically, beryllium oxide, amphoteric means it reacts with both acid and a base. Now when it reacts with an acid, HCl, yes, so just see here, it's going to form, what is this? Beryllium chloride plus water, right? BeCl3 plus water. Fine. Now the same thing. If I have to react beryllium oxide with a base, so with the base I'm going to take aqueous solution of this. Then this together is forming a aqueous solution means, and let me take water. What does it form? It's going to form a complex, coordinate covalent complex. Who is that? If I take sodium as 2 moles, what is this? It's going to form a complex called Na2. Close the square bracket. Beryllium is here, and here OH taken 4 times. 2 and 2. So 4 times. This is your complex which is formed. What is the name of this complex? This is called sodium berylate. Sodium berylate. Sodium berylate is a complex which is formed. So this is the concept, or this is the this one about information about oxides. Now let's come back and meet with hydroxides. Right, let us come back and study about hydroxides. We have already studied about hydrides, oxides and hydroxides. Now, what are the type of hydroxides alkali earth metals form? Basically, when I have to see, first one, it forms beryllium hydroxide, right? Right, valency of beryllium is +2, valency of hydroxide is -1. Next, after beryllium next is magnesium hydroxide, then calcium hydroxide, then strontium hydroxide, then barium hydroxide. Okay, these are the hydroxides. Now when I have to speak about basicity, basic nature about this, when I have to say, careful. Now why am I speaking about basic nature? Because the presence of OH minus ion, correct? Now beryllium is less basic. The order of basic nature, basicity is, beryllium is less basic than magnesium hydroxide, which is less basic than calcium hydroxide, which is less basic than strontium hydroxide, which is less basic than barium hydroxide. Yes. Now what is the reason? We'll see. Now what happened as we are moving down from top to bottom? First is your beryllium, magnesium, calcium, strontium and barium. Now what is happening in this case from top to bottom? Yes, what is increasing? Atomic size is increasing, or atomic radii or atomic size is increasing. When the atomic size is increasing, what will happen to the ionization enthalpy? Ionization enthalpy will become less. Less energy, I can pull out the electron. When ionization enthalpy is less, what will happen to the bond between metal and hydroxyl? The metal and hydroxyl bond will become weaker because the size is increasing. When the size, right. So next, when the metal and hydroxyl bond is weaker, I can easily break this bond. When I can easily break this bond, release of OH minus becomes easier. Yes. So now what is the concept? Metal bond is weaker. So what will happen? Release of OH minus is easier, isn't it? So release of OH minus is easier. When release of OH minus is easier, what will happen to the basicity? Basicity obviously will be high. That means the size is larger, ionization enthalpy is lower, metal bond between barium and hydroxide group is weak. So easily it can donate the OH minus, hence it is a stronger base. Release of OH minus is easier, hence BaOH taken twice is a stronger base than BeOH taken twice. Yes, this is the concept. Fine. So next, when I have to speak about the nature of this beryllium hydroxide, when I have to speak, it is an amphoteric hydroxide. A amphoteric hydroxide. Remember that. So remaining all not a problem. It's easy. So remember as a special point, beryllium hydroxide is an amphoteric oxide. It reacts with both acid as well as base, which I have shown in the earlier this one, that is in oxides. Now let us come back and start. Do one question which is very important based on hydroxide. Right. Now let us do one question related to your solubility of hydroxide. So why are hydroxides less soluble in water as compared to alkali metal hydroxides? Okay, very nice. So basically when I have to speak about alkaline earth metals, so let us write the hydroxides first and support that question to this answer. The first hydroxide is beryllium hydroxide. Second hydroxide is magnesium hydroxide. Third is calcium hydroxide. Fourth, strontium hydroxide. And fifth, barium hydroxide. Now when I have to speak, beryllium hydroxide, magnesium hydroxide are incompletely, they're insoluble in water. So they are insoluble in water, right? When I have to speak about this, calcium hydroxide and this one, they are sparingly soluble in water. This calcium hydroxide is sparingly soluble in water. And when I have to speak about barium hydroxide, strontium, they're readily, immediately, as soon as you dissolve in water, they're readily soluble in water. Now they're asking you readily soluble in water. So with this condition, what can I conclude? I can conclude that down the group, when I move from top to bottom, in this group, what is happening? Solubility is increasing. Okay, when the solubility is increasing, what is a factor which you can immediately relate? That means when this is soluble, it can easily release OH minus ions. When it is releasing OH minus ion, what is increasing? Basicity is increasing. Very good. So from top to bottom, solubility is increasing means basicity is increasing. This is the concept. Yes. Now let us relate it with hydration enthalpy and lattice enthalpy. Whenever they ask you, try to speak in terms of hydration enthalpy. So what is hydration enthalpy? Hydration enthalpy is, suppose if I have to take hydration enthalpy, is, if I have to speak in simple terms, it is a bond formed between the atom and water molecule. Or the energy released. The energy released when a bond is formed between an atom and water molecule, right? Now, so when I have to speak in terms of alkaline earth metals, the hydration enthalpy remains unaltered. It will not change from top to bottom. That is the first thing you have to remember. So hydration, okay, let me write it as delta H. That is delta hydration enthalpy. What is it? It's remaining unaltered because the bond formed between the atom and water molecule, right? So unaltered, it will not change. Now I'm going to speak in terms of lattice enthalpy. So when I have to speak about lattice enthalpy, now as I go down, fine, so what is happening? The ionic size is increasing, obviously, because number of shells are increasing. When the ionic size is increasing, the lattice enthalpy starts going down, it starts decreasing. So that is the important concept here. So what do we say? From top to bottom, as ionic size increases, what is increasing? Lattice enthalpy starts decreasing. Lattice enthalpy starts decreasing. Now we also have a formula, isn't it? What is on this? What is that formula? Let's see. Delta H lattice enthalpy minus delta H hydration enthalpy. Hydration enthalpy is equal to delta H solution. Okay, this is what we have studied. So according to this concept, the alkaline earth metals have lesser solubility compared to alkali earth metals. So now let us come back and learn the reaction with water. One question was asked in one of the NEET paper, so I thought I'll cover this concept so that we can relate this concept when we do the MCQ. Now let's come back and see the reaction with water. So when I have to speak about the reaction with water, so one important concept, like it's not a concept, basically some more small information. When I have to speak about all the metals, beryllium, magnesium, calcium, strontium, barium. Right now, among this, beryllium is the only alkaline earth metal which will not react with water, both the room temperature as well as boiling water. So it's not going to react with water, both the conditions. Room temperature also it will not dissolve, boiling water also not dissolve. When it comes to magnesium, magnesium dissolves only in boiling water. Remember that. So when I have to speak about calcium, strontium and barium, all the three will immediately dissolve in water. Vigorously they're going to dissolve. So they will vigorously soluble. Right. So now let me speak after giving the general information. Remember this. If they give you an option, don't try to put a product form, no reaction. Right. So when I have to speak, what is the type of, what is the reaction or general reaction which forms? Suppose when I take this metal, any of these metals, okay, except beryllium, solid. Now I'm going to dissolve this in water. So when I dissolve this in water, what will happen? Obviously, it will break up into ions. This will become M+2 because it is a bivalent cation. Isn't it? Group 2, isn't it? Right. Apart from that, in this water molecule, you have H in OH. This OH comes out as OH minus. Apart from that, hydrogen is still there. Hydrogen is still there, which is this. Now, let us balance. Now, if I take, now OH is this one, isn't it? So let me take this as, instead of this, let me take 2. So this also will be 2. Now 2 2s are 4, 2 hydroxyl group and hydrogen gas. Simple, isn't it? Right. So now what should you remember? Suppose I said this is okay, soluble, boiling water. This is soluble or vigorously soluble in water. But how will you get beryllium? How will you combine when you have to dissolve? Only option is, if you want that particular beryllium to dissolve in water, beryllium carbide reacts with water. This reacts with water, beryllium carbide. Now what is the product formed with this beryllium carbide? When this reacts, first one, beryllium hydroxide. Now see here, we have prepared hydroxide like this only, and the leftover would be after beryllium hydroxide. The next one is methane. See here, this is very important for you. You need to remember this. Now let us balance. Here 2 2s are 4. Okay, so 4 plus 2, 6. Here, let me write this as 3. If I write it as a 6, now oxygen, if it is balanced or not, let's see. Okay, fine. So beryllium is 2. Let us balance from beryllium and see. Okay, let me see. Beryllium is 2. So let me write 2. Now, how many hydroxyl groups are there? 2 2s are 4. 4 plus 4, 8. Right. So how many oxygens are there? Right, 2 oxygens. 2 2s are 4. Okay. So here 4 hydrogens. Here 8 hydrogens. So let me write this as 4. Now let's see. 4 2s are 8 hydrogens here. 2 2s are 4 plus 4, 8 hydrogens here. Beryllium is 2, beryllium is 2, oxygen is 4, oxygen 2 2s are 4. This is the balanced reaction. This is how you can prepare. But when I have to speak this for solubility, the solubility is very much less compared to alkali metals. So remember that concept. So this is the important information which you require for when you see the reaction with water. Let's come back and do so we'll speak about carbonates and their order also. Right. So let's go back and speak about carbonates. Now when I have to speak about carbonates, let us see the order. So first of all, carbonates, beryllium carbonate, right, is, if I have to speak in terms of solubility, right. So beryllium carbonate, solubility is greater than calcium carbonate, magnesium, right, I'm sorry, magnesium carbonate, which is greater than calcium carbonate, which is greater than strontium carbonate, which is greater than barium carbonate. Right. So now what is the reason? So reason is, now when I have to speak about, whenever a solubility concept is given to you, or whenever a stability concept, or solubility rather, KSP, we speak in terms of KSP, isn't it? Let us take. Now when I have to speak about barium carbonate, now we are writing the reason why is it less. Why is the solubility less compared to beryllium? So this particular thing, when you dissolve it in water, it breaks up into Ba+2 plus CO3 minus 2. This is an aqueous state. This is also an aqueous state. Now when I have to calculate the KSP value of this, KSP is equal to the product by reactant, right? Normal, right? So when I have to speak about the KSP value of this particular thing, it was found to be 5 into 10 raised to the power of minus 9. Which is very, very smaller value, isn't it? Yes, so 10 to the power of minus 9. So what is the important concept which you should remember? If KSP is higher, solubility will be more. Remember that solubility is more. This is the important thing. Which KSP higher means solubility more. Right. So let's come back and discuss about the sulfates now. We have discussed about hydrides, oxides, hydroxides, reaction with water, carbonates and sulfates. Now let us come back to sulfates. Now I need to discuss about sulfates. So when I have to speak about sulfates, what are the type of sulfates alkaline earth metals form? First of all, the first sulfate is beryllium sulfate. Then after this, calcium sulfate. Okay, beryllium, magnesium sulfate. Then calcium sulfate. Then strontium sulfate, then barium sulfate. When I have to speak about the solubility of the sulfates, you may be asked question based on solubility. Let's see this. Beryllium sulfate is more soluble than magnesium sulfate, which is more soluble than calcium sulfate, more soluble than strontium sulfate. Now when I have to speak about these two, they are almost, they're insoluble in nature. Why are they insoluble in water? Let us see the reason. Basically, whenever you are going to speak about solubility concept, remember, either you'll speak in terms of KSP, that is one. And the second important thing, you can speak in terms of two important concepts, that is hydration enthalpy as well as lattice enthalpy. Remember this, lattice enthalpy. Right. Now what is this? Suppose if the hydration enthalpy is greater than lattice enthalpy, the hydration enthalpy value, that is when the bond energy released when the bond is formed between the atom and the water molecule, if this is higher, then the salt is soluble in nature. Now the same thing the other way around, if hydration enthalpy is lesser than lattice enthalpy value, this is lesser, hydration enthalpy when the bond, if the energy released is less when bond is formed between an atom and water, or water and atom, then that particular atom, metal atom, then if this is less, then the salt is insoluble. Now let us come back to this case. So when I have to speak about barium sulfate, in case of barium sulfate, the hydration enthalpy is lesser than lattice enthalpy. Right, so because of this reason, you can directly write that, because of this reason, why? Once again, in case of BaSO4, hydration enthalpy is less than lattice enthalpy. Right, the amount of energy associated when one mole of an ion is formed from its gaseous atom, that is lattice energy, isn't it? Lattice enthalpy. Right, so hydration enthalpy is less than lattice enthalpy, hence barium sulfate is insoluble in water. So when I speak about this one, beryllium sulfate, this is the other way around. Hydration enthalpy is greater than lattice enthalpy in this case. In case of barium sulfate, hydration enthalpy is less than lattice enthalpy in this case. That's it. Right. Let's come back and speak about halides of alkaline earth metals. Now, when I speak about halides, let us see what is the type of halide it's going to form. Now, basically, your metal combines with halogen. Now, X can be fluorine, chlorine, bromine, nitrogen. Right. So, they're going to combine and form halides of type MX2. Now, let us see. Now, if I have the same thing, let me write M, metal combines with HX. Metal oxide combining with HX. Metal carbonate combining with HX, metal hydroxide also combining with HX. Everywhere, let me take 2 moles of this. Now what happens when it combines? The first thing, it's going to form an halide of type MX2 and the leftover hydrogen. Now in this case, MX2 of water. In this case, it's going to form again the same type of salt, MX2, and what I'll be left with? Water and carbon dioxide. Water and carbon dioxide. Now, in this particular case, again MX2 type, MX2 plus water. Okay, there's no carbon dioxide. So, to balance that water, I'll write 2. 2 2s are 4, 2 2s are 4. Right, these are the different types of this. Now, when I have to speak about beryllium halides, right, like let's come back and see beryllium halide, how is it dissociating? So it's going to form a complex of beryllium halide. Beryllium forms a coordinate covalent complex with ammonia. Let's see that. Right, when we speak about the nitrides of group 2, that is alkaline earth metals, they're going to form nitrides of type M3N2, right? The valency of nitrogen is 3 and the metal is divalent in nature, so +2. So when I have to speak about calcium and nitrogen, so let they both combine to form CaN. Now, right, nitrogen valency is 3, calcium valency is 2, so 3, so 3. So when I have to speak about magnesium, magnesium combines with nitrogen forming again MgN. Valency of nitrogen is 3, valency of magnesium is 2, because magnesium is 3 here, that is 3. So these are the types of nitrides formed, the ionic compounds which are shown by alkaline earth metals. Right, now let us come back and learn the structure of beryllium chloride. So beryllium chloride shows two types of structures. What are they? One, let us write that. One would be, it's going to show a structure in vapor state, one structure in vapor state, other in solid state. Let us write. So when does this show what type of structure, which temperature also you should remember? Vapor phase. Okay, let us write that as vapor phase is one type of structure. Second is in solid phase. Right. So when I have to speak about vapor phase, here the temperature maintained is greater than 1200 Kelvin, then shows in vapor phase. Now when it comes to solid phase, it is less than or below 1200 Kelvin. Right. So when it is in vapor phase, remember this is going to show a monomer, only monomer. But when it comes to a solid phase, it exists as a dimer. Right. And next important thing, when I speak about monomer, the shape of the molecule is linear. Here when I have to speak about solid phase, here dimer, the shape is, or if I have to speak, it is in the form of polymeric chains. I'll draw that chain, you will understand that. Fine. So when I have to speak about this, it is zero dipole. There is no distance charge, zero dipole moment. Now let us see the structure. It's a linear. So beryllium chloride, isn't it? BeCl2. So beryllium in the center, one chlorine here, one chlorine here. This is the structure in vapor phase. Now when I have to speak about the solid phase structure, I said polymeric chains, isn't it? So polymeric chains means how is this formed? Beryllium is here, right? One chlorine is attached here, one more chlorine is attached here. There's one more beryllium right here. Now this is bridged with one more chlorine, bridged with one more chlorine. Now again this is again bridged here, this is bridged here, and this chlorine and this chlorine. This is how is the polymeric chain. Now let us write the bond angle. Here in this case the bond angle is 98 degrees. Fine. Now the bond, this in between this beryllium and chlorine, this is 206 picometer, and from here till here it is 263 picometer. Fine. So this is what is the thing. Fine. Remember 202 picometer. So this with the structure. So remember when the exam they ask you solid state and vapor phase, you need to remember this data. This is the polymeric chain. Here when I have to speak, they are bonded with covalent bonds here. They're also bonded with coordinate bonds also. So two chlorines with covalent bond, two chlorines with coordinate covalent bond. So both two types of bonds are existing with beryllium and 4 chlorines around. With beryllium 1, 2, 3, 4. Here it is only linear structure. In this way, this gets cancelled, this dipole gets cancelled. So the net moment mu is 0 in this case. And to the last topic of your alkaline earth metals, that is compounds of calcium. So we have studied a lot about beryllium, magnesium, now about calcium. So when I have to speak about calcium, we're going to study about compounds, which is the first compound is limestone. What is the formula for limestone? It is calcium carbonate. The next one we're going to study about quicklime. What is quicklime formula? It is calcium oxide. Then we're going to study about lime water or slaked lime. Slaked lime, the formula is calcium hydroxide, lime water. We're also going to study, correct? Yes. So these are the compounds. Now let's start. So when I have to speak about calcium carbonate, how can I prepare now? Let me write. We're going to prepare limestone. So for preparing limestone, I'm going to take slaked lime. Right? To this we are going to add carbon dioxide. Then what will happen? Calcium carbonate is out and water. This is the preparation. Now this is a precipitate. Now the same thing if I have to prepare quicklime. Simple, isn't it? So I'm going to take calcium carbonate and I'm going to heat it. What temperature? Almost around 1170 Kelvin temperature. I'm going to heat 1170 to 1230 Kelvin or something, almost to that. Then this dissociates into calcium oxide plus carbon dioxide. Simple, isn't it? Nothing else. We're just decomposing it. Now let's come back and see certain reactions of calcium carbonate, certain reactions of quicklime, that is calcium oxide. This is your calcium oxide, this is your limestone, and we'll see some more reactions. Right. Let's see the reactions of calcium oxide. So when I have to speak about the reaction of calcium oxide, if it reacts with water, simplest reaction. What is that? This is again going to form, water is something you can write letters H or H. It's going to form calcium hydroxide. Right, so this is calcium hydroxide and your water. Fine. So next important thing, if it reacts with silica, that is sand, it's going to form calcium silicate, which comes out in the form of a slag, isn't it? So in your metallurgy of iron, calcium silicate. Now the same thing, if calcium oxide reacts with P4O10 with phosphorus. Fine. So what is the compound formed? Simple, isn't it? Nothing to remember, just memorize. Take calcium, write here. Phosphate, write it as PO4. Phosphate valency is 3, write this. Calcium valency is 2, write this. Calcium phosphate. Now here phosphorus, okay, now I need to balance this. So make this calcium, if I have to take 2. Now let's see this. 4 3s are 12. Okay, then this also becomes 2 calciums. Now let's see the oxygens. 4 3s are 12. 4 3s are 12. 10 plus 2, 12. Phosphorus 3. Yes, okay, this is the reaction. Right, now let's come back and learn about slaked lime. So what is slaked lime? We have started with the compounds of calcium. We have studied what is quicklime, what is limestone and all this. Now when it comes to slaked lime, simple, isn't it? It is also called as calcium hydroxide. Fine. So this calcium hydroxide, when I have to speak about calcium, let us see the preparation first. So in the preparation, I'm going to take quicklime. This is quicklime. To this quicklime, we are going to add water. When you add water, what will happen? Calcium hydroxide, that is your slaked lime is formed. Now what is important here? This is quite common reaction. So what is important is this slaked lime, when you have two things you need to remember here. When this forms a suspension part, right? That means during the formation of suspension, the hydrogen gas is released. That means this hydrogen gas is released here and this acts as a suspension. Then we call it as milk of lime, right? Remember that. So we call this suspension as milk of lime. The same thing if it is in the form of a clear solution. Clear solution, if you get that, then I call this as lime water. Right? Simple as that. Yeah. So this calcium hydroxide slaked lime, the important application of slaked lime is, right, it can be used to prepare bleaching powder, right? So we were going to take that slaked lime. Let us see the application part of that. So if in the reaction if they give you, remember, it's calcium hydroxide, it's going to combine with chlorine and it's going to form 3 products. The first one, calcium, suppose if I take 2 moles of this, calcium chloride is formed, CaCl2 is formed. After that, calcium oxychloride, that is calcium oxychloride taken twice, and the leftover is water, right? So this is 2, this is also will be 2. So this is your bleaching powder which you have prepared. So calcium hydroxide, we're using it to prepare bleaching powder, one of the applications. Simple. Now let's come back and finish off the chapter by studying the 2 more compounds, that is POP as well as your calcium carbide. Right. One more thing you should remember in slake lime is slaking of lime. If they ask you what is slaking of lime, nothing. It is an addition of water. That is a limited addition of water to quick lime is called slaking of lime. Remember that once again. It is a limited addition of water to quick lime is called slaking of lime. That is a simple definition. Remember that. So let's come back and do POP preparation. Right, now let's come back and learn about POP, the simplest topic. So what is POP? Plaster of Paris. It is also called as calcium sulfate hemihydride, right? So the name is calcium sulfate hemihydrate. What is hemihydrate? Hemihydrate is nothing but half H2O. Right. So how should we prepare? Like I'll take both the ways. If I take gypsum, if I am going to heat this, correct, it's going to form POP. To the same POP, if you add water, it will form gypsum. Simple. Okay. So let us write the reaction. Now calcium sulfate hemihydrate, CaSO for half H2O is POP. Right, so because it is half H2O, it is called hemihydrate. The same POP, if I'm going to add 3/2 water molecules, see here to POP I'm adding water molecule. When you add 3/2 water molecules, what will happen? This half, right? 3 plus 1, 4. 4/2 is 2, isn't it? So whatever you get, calcium sulfate dot 2H2O. So this is your gypsum. This is what you get. Now the same thing. Now suppose if this whole thing happens at 373 Kelvin. Now the same thing, suppose if I'm heating this plaster of Paris above 390 Kelvin. If I'm heating it above 390 Kelvin, then it's going to set up, or it's going to lose this water of crystallization above 390 Kelvin, and it will form into a hard mass. That burnt plaster is called that particular mass or hard mass is called burnt plaster. Remember that. So above, beyond 390, start heating, so it will lose this water. Once water of crystallization is lost, it will become a hard mass, that is called burnt plaster. Right, now let's see one question based on calcium carbide. So one quite common question asked, let's see the reason first. What is this? Why should calcium carbide be stored in sealed containers? So for that, let us see the preparation of calcium carbide. So when I have to speak about calcium carbide preparation, so how is this prepared? First I'm going to take quicklime, calcium oxide. To this I'm going to add coke, carbon. Right, so what is it going to form? Let me take 3 moles of this. Then automatically it becomes CaC2. So 2 of this picks up the CaC2, calcium carbide, and the leftover, how many are there? 1, isn't it? That comes out as carbon monoxide. That's it. Right. Now what do they ask? Sealed container. Right. Well, let us read the reason. Why sealed container? This calcium carbide which is prepared, suppose if this combines or if it is exposed to moisture, water, right? So immediately what happens? This calcium carbide, it's going to absorb moisture. This particular thing, it's going to absorb water present in the atmosphere, water moisture, and it's going to form calcium hydroxide, right? Calcium, this is written as HOH, isn't it? So calcium hydroxide, what is left out? It is left out is C2H2. So because of the formation of calcium hydroxide or lime water, they just recommend to store calcium carbide in sealed containers. Right, now with this I've completed the S block elements perfectly. Cement, I think you can study nothing much information, you can study the composition of that. Now let us start solving the neat questions. I'll be doing almost 300 questions for this chapter. 300 questions, each one will be relating to the concept which I have taught.